So I can't cancel the way this is, but with the rules with limits to infinity is that the highest powers dominate. So I can say that this is the same thing as saying limit as x goes to infinity. The highest powered term in the numerator is x squared. Highest power term in the denominator is 3x to the fourth. Notice I carry the coefficient in both cases. So again, I can cancel. So I get 1 over 3x squared. Put in infinity, I get 1 over infinity. That's 0. Again, make sure you're only doing this with x's to infinity. So limit as x goes to infinity, highest powered term from the numerator, highest powered term from the denominator. Cancel the x squareds, I get 4/3. This one here, I know you are clever enough to figure out what the highest powered term is without multiplying it all out. So I can see that the highest powered term would be 6x to the 6th if I did multiply it out, but I know you don't need to. In the denominator, if I multiplied this out, I get negative 2x cubed. So then I'm going to cancel because I can. So I'd get a negative 3x cubed. Substitute infinity. X is to infinity cubed is infinity. Negative 3 times infinity is negative infinity. Okay, again, highest powered terms with all of its coefficients. So from the numerator, I can see I get negative 9x squared. From the denominator, looks like I get 5x to the fourth. So then cancel, limit as x goes to negative infinity. So I get negative 9 over 5x squared. It's infinity squared. It's infinity. Negative 9 over infinity. It's 0. All right, so let's do this last one, carrying along highest powered terms with its coefficients. So I'd have a negative 24 x to the fourth. In the denominator, I'd have 20 x to the fourth. Well, look at that. Those cancel. Negative 24 over 20. That's a fine answer. It's not necessary to go and simplify for me. Okay, so we know 0 over 0, infinity over infinity, those mean more work. There's something to be done. So I'm adding to that infinity minus infinity. Okay, this would be infinity minus infinity. There's only one thing we can do, and that is multiply by the conjugate. So let's do it. X squared plus 2x. Remember, you have to multiply numerator and denominator by the conjugate. And so this denominator is just 1, right? So this is going to give me limit as x goes to infinity. So remember how conjugate works. Let me make this bigger here. So I'd get the first terms, so that would give me x squared. Outside, inside terms cancel. And so the last term would be these two radicals multiplied together. So I'd get a negative, and be really careful. Make sure you put the parentheses in. And then the denominator is this. Okay, so let's take the time to distribute that negative through. So I get x squared minus 2x, x plus x squared plus 2x. Okay, so I can see the x squareds cancel. So I'm left with a negative 2x in the numerator, and in the denominator, I've got that. Okay. So now, if I'm looking at picking up the highest powered terms, I can see 2x in the numerator. Okay, so let's do that. 2x in the numerator, negative 2x in the numerator. Okay, this is a term that's x to the 1 power. And then really, if you thought about this, square root of x squared, that's like an x to the 1 power. And since we're taking highest powers, I'd be taking this, and this one just fades off in the distance, like those extra terms we did before. So you know, and I even reminded you right here, this square root of x squared turns into absolute value of x. That's a big deal. So we need to go use the absolute value definition. And think about where we're going. We're going to positive infinity. So when we have positive numbers that we're plugging into our absolute value, like absolute value of 2, we get 2. So this is a positive number, so we just get itself, x. So then last step would be to add these two things together in the denominator, cancel the x's, I get -1. So it's really important to me, I want you to show, to get going from this step here, all of that down, and showing me you get the absolute value from here, and then showing me the absolute value of a positive number gives you x, then you can finish it off. So these steps are really important.